Good day everyone. In this video, you are going to learn a new method of integration called integration by parts. The name suggests we are going to have the integral as two parts and then we are going to integrate. Okay? Let me explain to you in which cases or to what type of sums we will be using this method. You have a direct formula for log x and inverse trigonometric functions in differentiation, isn't it? Whereas you don't have such a direct formula in integration either for log x or for inverse trigonometric functions as sine inverse, cos inverse, tan inverse, like that. So to integrate such functions, we use this method, integration by parts. Then the second case is, in the integral, if you have a product of two different functions, that is like an algebraic function and an inverse trigonometric, like x into sine inverse x, x into tan inverse x, like that. Or you can have a logarithmic function and an algebraic function, like that. When you have a product of two different functions, in such cases also we use this method, integration by parts. Okay. Here the only formula you should know is integral u dv is equal to uv minus integral v du. The given integral I, you will be expressing, that will be in the form u dv. There will be a u function and there will be a dv part, that is the remaining part of that integral along with dx, that we call as dv part. Then this is uv. Here you need not do anything, that is part of your answer. The integral v du will be easily integrable by any one of the methods you have already learnt in integration. Okay? As and when I do the sums, you will understand this clearly. In some books, they will give the u function as f of x and the v function as g of x and du as f dash of x and dv as g dash of x. But this is a bit easy for us to write, so I am using this. So let me teach you the model 1, that is how to integrate a logarithmic function or an inverse trigonometric functions. Okay, in that I will do now first example, that is example 1. I is equal to log x dx. Already I told you there is no direct formula, so we are going to use this method and get the answer. Okay, here the log x is the only part of our integrand, so that will be our u function. So write u is equal to log x. So only dx remains, so dv is equal to dx. Now you have to differentiate u to get du. You have to integrate dv to get v. Okay, so now you differentiate this, you will get du is equal to 1 by x dx. Here you integrate it, you will get v is equal to x. Don't put c here, c we will add in the last. Now you know u, you know du, you know dv, you know v, right? Now write the formula, integral u dv is equal to uv minus integral v du. Okay, now this I told you, that will be your I. Let us check it. U is log x and dv is dx, so log x dx. So I will put I here, that is equal to uv log x into x. Don't multiply that x with the x in the log part. Okay, so you better write it as x log x minus integral v is x, du is 1 by x dx. Cut this. So now I will get x log x minus integral dx is nothing but x, so you will get an x, then plus. Do you understand? Now example 2. I is equal to integral sine inverse x dx. Here sine inverse x is the only part, so take that as the u function. U is equal to sine inverse x. So the dx, dv, that will be equal to dx. Now you know you have to differentiate the u part, you have to integrate the dv part. Okay, so now du will be equal to 1 by root of 1 minus x squared dx. Okay, then you will get v is equal to x. Don't think in all the sums you will get dv as dx. In this model, of course, you will get. Now, write the formula. Integral u dv, that is equal to uv minus integral v du. This is sin inverse x dx, so that is I. That is equal to uv sin inverse x into x. I will write it x sin inverse x so that it will be clear to you, right? Then minus v is x and du is 1 by root of 1 minus x squared dx. This part always, no, you need not do anything. So leave it as it is. Come to this part. Now, the numerator you have just an x. In the denominator you have root 1 minus x squared. That is x squared is there. You know, when you differentiate x squared, you will be getting some x, no, that is 2x. So, you have to integrate it using the method of substitution. Okay. So, here for this part alone, I will write 1 minus x squared is equal to t. You may remember in substitution, generally we will substitute what is within the square root, what is within a bracket, what is in the angle part, what is in the exponent part, like that. So, now put 1 minus x squared as t. When you differentiate, minus 2x will be dt by dx. Keep the x here, bring the dx here. Here you will get minus 1 by 2 dt, right? So now, let me write I is equal to, I will write the first part as it is. Now the second part, the x dx, that is going to become minus 1 by 2 dt. The denominator is going to become root t. Okay. So now this minus into minus will become plus. So let me write a plus and take the half. Root t, if I take it to the numerator, that will become t power minus half. Okay. So I will write t power minus half dt. So x sin inverse x plus half. When you integrate t power minus half, you will get t power half by half, then put 1c. This half and that half will get cancelled. So now you will get x sin inverse x. What is t? T is 1 minus x squared. So t power half means it is root x. So you will get plus root 1 minus x squared plus c. So this is the integration of sin inverse x. Here in the VDU part, to integrate you are using substitution. So any method may come. Now you have to practice the other inverse trigonometric functions as cos inverse x, tan inverse x, cot inverse x, cosecant inverse x and secant inverse x. Then you will become thorough with this first model. Hope this model is clear. Can we move on to model 2? In model 2, you will be getting a product of two different functions in the integral. So, you should know which function you have to take as u function and which other function along with dx you have to take it as dv. Otherwise, you cannot proceed. You cannot just like that take any function as u and any function as dv. That won't work out. You won't be able to integrate properly. For that, there is one simple rule which will help you to identify the u function. That rule is called I-late. Okay, I-late means I is inverse trigonometric functions, L means logarithmic function, A is algebraic function, T is trigonometric function and E is exponential function. Okay. So there are 5 types of functions in maths. Any expression, mathematical expression, we can bring under these 5 categories. Inverse trigonometric, you know the 6 inverse trigonometric functions. L is log anything. A is algebraic function, any x power formula, right? Even a constant is called algebraic function because that is x power 0. T is trigonometric, all the 6 trigonometric functions. E is exponential. Okay. Here, the order of the letters help you decide which function you have to take it as U function. Let me explain by an example. Now see this sum. I is equal to x secant squared x tan x dx. You may wonder, here you are having 3 terms, isn't it? Okay, but here the x is an algebraic function, right? Both the secant squared x and tan x, they belong to trigonometric functions. So you have to combine the two together. So you are having a product of an algebraic function and a trigonometric function. So algebraic function is A, trigonometric function is T. A comes before T. So the algebraic function, you should take it as the U function. The trigonometric function along with the dx, you have to take it as dv function. Is it clear? Okay. Just another example I will give orally. If you have integral x sine inverse x dx, okay. X is the algebraic function. Sine inverse x is an inverse trigonometric function. I comes before A. So you have to take that sine inverse x as the u function. And the x with the dx, you have to take it as dv. So this rule is very, very important. You cannot just like that assume the u function, okay? Then you won't be able to integrate the dv part. That is the integral v du part, okay? So here, for this sum, you are going to take your u as the x, right? Then this total thing is your dv. So the dv is secant squared x tan x dx, right? Now, as usual, differentiate this, you will get du is equal to dx. You integrate this, you will get here v. But here, it is not that easy for us, isn't it? It is not a straight thing. So here, I have to use some method of integration to integrate. So first, I am not going to write v because I want to integrate both sides in a particular step only. So now, as for this side, I am going to substitute tan x is equal to t, because I know when I differentiate tan x, I will be getting secant squared x, right? So now, when I put tan x is t, I am getting secant squared x is equal to dt by dx. So secant squared x dx, that is going to be dt. So now you can see this is t, that is dt. So now you write integral dv is integral t dt. Now let us integrate. We will get v is equal to t squared by 2. What is t? T is tan x. So I will get tan squared x by 2. Is it clear? So in the part, that is in dv part, to get v itself, we have to use some method. Here we have used substitution method, right? So now you know u du dv v. Now let us write the formula. Integral u dv is equal to uv minus integral v du. The left hand side as usual, that is I. So I is equal to uv. U is x. V is tan squared x by 2. So tan squared x by 2 minus integral v du. V is tan squared x by 2. Du is dx. Okay. So now let us take the 1 by 2 outside. So I will write I is equal to x tan squared x by 2 minus 1 by 2 integral tan squared x dx. Do you have a straight formula in integration for tan squared x? No. So now you have to remember the trigonometric identity, isn't it? Tan squared x can be written as secant squared x minus 1, and for secant squared x you have a direct formula. So like this you have to always recapitulate the trigonometry formula and whatever you have studied earlier so that you will be able to integrate. So now I will write this is x tan squared x by 2 minus 1 by 2. This I will write secant squared x minus 1 dx. Now I can easily integrate. So now this is x tan squared x by 2 minus 1 by 2. For secant squared x it is tan x. Here you will get x plus c. If you want you can take the 1 by 2 common out and write. But anyway we cannot make it simplified, no? So let us leave it like that. So here in this sum you learnt a new rule I late, and you also learnt in the dv part we are using substitution to get our v. Okay, is this sum clear to you? See the example 2 now. I is equal to integral x cube tan inverse x dx. Here x cube, that is algebraic function. Okay, tan inverse x is inverse trigonometric function. As per the Eilate rule, now we have to take tan inverse x as the u function. So let me write u is equal to tan inverse x. Then dv will be x cube dx. I think now you will be clear about how to identify the u function using the Eilate rule. Okay. Now differentiate the u function. Du is equal to 1 by 1 plus x squared dx. Right. So you should remember all the differentiation formula also. Now here you integrate. You will get v is equal to x power 4 by 4. Now write the formula. Integral u dv is equal to uv minus integral v du. Check whether your LHS represents the given I. You have here tan inverse x, here x cube dx. Okay, you have to check whether everything is covered. So now write I, that is equal to uv. So let me write x power 4 by 4, then tan inverse x minus integral v is x power 4 by 4, du is 1 by 1 plus x squared dx. Now I can take 1 by 4 out from the integral. So I will get x power 4 by 4 tan inverse x minus 1 by 4 integral x power 4 by 1 plus x squared dx. Now let us look at the integrand. You have an x power 4 in the numerator. You have 1 plus x squared in the denominator. Now what concept you should remember? The numerator is of a greater degree than the denominator. So it is called an improper rational function. So divide, that is the first step. Divide and then only you can integrate. Okay. So actually how to do the division. But in this particular sum, I can teach you an easier way. That is, without dividing, how we can bring that quotient plus remainder by divisor form. That will be easy. You can learn it, but you cannot use it for all the sums. But here, because it is x power 4 and here it is 1 plus x squared, I will be able to make use of that. Okay. So now, I am going to write the first term as it is. Then in the second term, I am going to add and subtract 1 in the numerator. Okay. When I do the next step, you will understand why I am adding and subtracting 1. So now my I is equal to x power 4 by 4 tan inverse x minus 1 by 4. Now I am going to group x power 4 minus 1 by 1 plus x squared, and I am going to write 1 by 1 plus x squared dx. Okay, do you understand what I do? This x power 4 minus 1 by 1 plus x squared, then that plus that other one by 1 plus x squared. Okay. Now write this as it is minus 1 by 4. This is like a square minus b square. You know the formula? That is a plus b into a minus b. So you can write that x squared plus 1 into x squared minus 1 by 1 plus x squared. Write this as it is for everything dx. Here this and this will get cancelled. So now I am getting x power 4 by 4 tan inverse x minus 1 by 4 integral x squared minus 1 dx. Now this will be your quotient if you do the division, and the 1 will be the remainder. This is the divisor. So now I got it by adding and subtracting and splitting. If you think it is easy, you can use this method. Otherwise, you can go for the normal long division method. Okay. So now you have got like this. Now it is very easy for me to integrate. So I will write x power 4 by 4 tan inverse x minus 1 by 4. For x squared you will get x cubed by 3. For that 1 you will get x. Then here you will get tan inverse x. Then plus c. Right? Of course 1 by 4 is common for everything. So now let me take the 1 by 4 common for the total thing. So I will get here x power 4 tan inverse x. Then minus I will get x cube by 3. Then here I will get plus x. Okay. Then here I will get minus tan inverse x plus. Do you understand this sum? So each sum I have taken a bit different so that you can understand. So the two models, I don't want to thrust too many things in one particular video or in one particular thing. So I will do other model and some other sums in the next video. So today what you have learned, just I will give you a gist. Integration by parts. That method we use in two cases I told you, right? One is to integrate log x and inverse trigonometric functions. There will be only one single term in your integrand. That you will take as u function. The dx will become the dv. You will use the formula integral u dv is equal to uv minus integral v du, right? Then the second model, in the integrand you will be getting a product of two different types of functions. There we use the rule isolate to identify which to take as u function and which other function along with the dx will become the dv function, right? In that sometimes you have to integrate the dv part. There itself we will use some method. Sometimes in the integral v du part we have to use some other method of integration which you have already learned. So I hope these two models are clear to you. Please do the same model sums from your textbook. Then you will be very clear. Unless you practice yourself, nothing will be clear. You may seem to understand when I explain, when you see the video, but you do it. Then only you know where you are getting stuck and how to clear it. Okay? Thanks for watching the video. Share it with your friends and classmates. Thank you once again.